finally, we are going to finish this part with an exercise based on general data. We are going to use Titanic dataset. You can Google Titanic Kaggle dataset and download the CSV. We will be also adding the CSV to the main training video, main training files for this video mentioned in chapter 1. But again, you can Google for it quickly, and it's just a CSV file. We're going to start with this. It's a non-CRM use case. It's an external data, and we're going to show you how the actual tool looks like. So you are going to log into your environment, then navigate to your Analytics Studio. Once you are in Analytics Studio, you are going to create a data set, and you are going to select a CSV file for that. And if you have downloaded the CSV file, you just click on it and select that CSV file. And I am going to use the Titanic CSV file. So I'll use this one. And I'm just going to give it a tag. Let's say 14 April. So you want to, from the get-go, you want to pay attention to a few things. So first, this data set, we are going to try to use it to predict survival likelihood. We see survived is yes or no. It's a text, so that's important. It's a text, is not a number. And this is what I'm going to try to predict or read the story at least about. And it's a binary because there's only two values, no, yes, yes, no. I think this is clean. If you download the raw file, this is 1 or 0, so you can just change it to text, yes, no. Or what you're going to do is, as you go along the, or take a look at the other fields, you need to pay attention for the ones that should be dimensions versus measures. So for example, P class, this should not be a number. I mean, we will be able to, bin it in that particular and control the bin. But again, to make things simple, this should be a dimension. So I'm going to go and change it to a dimension because again, this is the class fair. So it's 1, 2, or 3. I don't add these numbers up. It's a label. It's a feature. You remember, it's a value of the dimension. Name is unique. Okay. Sex or gender is, again, this is still a text. I'm fine. Age is again, is not something I add up. I don't add these two fields and add their ages. So age should be a dimension. So if I click on age, this also should be a dimension. This is just like zip code. Sometimes engines read it by, as a number, and it should be a dimension. Siblings, how many spouses or siblings you have? Okay, this is a number. We will leave it as a number. How many parents? Yes, we will leave it as a number. And fair is a number. So now that I've cleaned my data and looks like this, age, sex, name, P class, and survived, I'm going to upload that file and create that data set. Now, while that data set is being created, I have a similar data set, but I do want to, well, this finished fast. So remember what I said, after you create the data set, it is recommended to go what? Not just create the story. Go to explore it first. Take a look at the data itself. So we're going to explore it. I know it's 887 rows, but that's it. Let's explore it. Exploring the data, again, because we're dealing typically with business use cases or simple, let's say, at least in this case, it's not a lot of dimensions. I should be able to take a look, for example, at things. Again, this is simplified, but if you hear, for example, unbalanced data set, well, I'm going to look at survived, right? So if I group by survived, I have a good distribution. I have 545 did not survive, 342 survived. I don't have, like 10 only survived and everybody else no. That would be unbalanced. So I can determine right here that, okay, for that particular variable, it's fine. I can go forward with this. Now, of course, this is just a simplified way, or first check. There are other checkpoints you can figure it out, but this is simple exploration. I can also see like, okay, how many female and male I have, and I can see, okay, so I have less female. Okay, something maybe to keep in mind. P classes, I have again a good distribution, most of them third class, etc. And I have the other metrics. Now this data is simple. In another exercise, you will see we spend a bit time here looking at it, but I haven't found any major insights yet. So I'm gonna go create story from here. List length I haven't saved, so it's going to go away unless I save it. But I just want to go to create story. Right now, whatever I group, whatever I filter does not carry to the story. So even if I filtered here and I hit create story, it takes all the data set. And in this particular data set, what I want to do is maximize, not this number, I want to maximize survived yes. I want, let's say, hypothetically, what could have survived my likelihood to survive. I'm going to create the story in this app, in this folder. Story type, I have two options. Insights only, that is the mini version where I'm not building a model behind it. I'm just finding all these relations between the values and their pairwise interactions so that I can deduce which field has the most effect on being able to survive or not, just based on that data set, those 887, right? And we will see it in a bit. Or insights and predictions. Now I'm going to run it insights and predictions. The reason why, this is a small data set, I've run it a few times before, and I know it's not going to take a long time. Why? Because in production, remember that box, the first phase 100 plus, first time, a couple of times, you might run only insights. Because if you have a lot of fields, what happens is, when you run it with insights, it takes less time, and second, you get to. So again, I'm okay. I clicked here too fast. But second, it takes less. Again, if you select insights alone, it takes less time to create the story, and that is meaningful in the first run where you don't know which field you're going to include or not. So it is recommended if the data set is large, is wide, and this is the first time you're running it, you will run it only insights just because you want to save time. And the reason is if you do insights and predictions, it's going to take more time. And then you don't know if you come to the fields that are needed to be included or not, you might change your mind. So imagine you run the story first time, it takes, I don't know, half an hour. And the moment it comes back, you realize this field should not be there. I'm going to take it out. So you spent half an hour to make a modification of 10 seconds and then now another half an hour. Versus if you run it insights, you get it faster and you see that the field you need to remove. And then when you're good with it, you run it with predictions. I ran it here with predictions because it's a small data set. I have time. And I'm automating it, so I'm letting Einstein Discovery pick the fields that need to be included in the story. There's not a lot anyway. Manual is the ones I choose. So I'm going to create story, and this will create my story. Now, while this is creating the story, I do have it here. So I'm just going to click on it. And yeah, this is still analyzing. So I have this same one right here. And this is the story that I just created and the same thing. And again, these are the insights, the correlations right here. These are the ones that don't take much time, and they are great indicators to see if I need to, keep something or not. And from the get-go, what am I looking at here? So this is the landing page of a story, an Einstein Discovery. This is the survived, yes, maximize. I am looking at all of the variables. I said auto select, it selected all of them. The first one, sex, is the biggest correlation. Sex explains, that's the biggest factor, the biggest impact on survival, yes or no. And right there, if you are a female, you have more, likelihood to survive versus male. And then if you look at the fur, again, unfortunately, same. You can see that if you paid probably a higher fare, you have performed less. So if you can see here, the fare, again, higher fares had more likely to survive. Now those are typical. So again, these first insights are the first variables, the powerful ones comes on top. Then we take this variable with interaction with another, with a pairwise, right? So not only it's sex, but sex female and P class 3, sex female male P class 3, there is a significant difference in behavior that it needs to be called out. So for example, it says for male in P3, again, it's way much less than female in P3. That's what it's pretty much saying. And so you can see here, male in P3 is way less than male in P1 and P2, and even female, same thing. So although female in general, just being a female is not guaranteed to survive in this case, it's actually also, there are other factors. It's the P class in this use case. So, and again, you can see that every one of these charts is not just a typical dashboard. You just walk through it and you scroll down. There's actually a lot of information here. And what I explained in the slide, in the chart here, is explained in natural language right here. So I'm not going to go over all these. We are going to spend a lot of time in the other videos, reading stories. But this, the power of this is I provide the data set, immediately it figured out the relations between these values and what is affecting my survived yes. It's already spitting out these insights. I can dig deeper a little bit and go into sex here, for example, and say, notice this changed. Okay, so for survived sex, female is way above the average. So this is the average across the population. I have 887 records. If I look at all of these records, all of the females in general have more, survived yes rather than male. I mean, that's if you're looking for a simplification, simplified explanation. This is what it is. It's looking at the records. It happens most of the female have a yes, and most of the men have no. Now, of course, statistically, what is the percentage? What it is? You have it right here. How it's calculated. The average doesn't matter male or female. If I just add up the yes and the no and do the averages, that's the average 40%. Now, if I want to dig deeper a little bit into sex, there are two values right here, right? So I can go here and say, look, I'm gonna check into female. Why is it so higher than 74%? So if I click on female right here, and I can see, okay, this is why it's doing better, and especially in the classes too. But more importantly, I can click on why does this do better right here, right? And I can see one of the most powerful charts here is the component driver analysis, which is gives me why female is much more higher, or the value is higher to survive. Now, if you do this actually on your own and you don't see the explanations, make sure you can click Command minus or zoom out. Just make sure you zoom out so you can see the explanations. Again, we'll cover this a little bit deep in the other videos, but what's happening here is this is the global average. This is the 38%, 39 right here, 39. This is a real number in my data. This is a real number. And for female, if I look at my data set and I filter only for female and I calculate the yeses versus the no for survive, the average is 74. This is a real number. This is a real number. Because I ran the story with insights and predictions, what Einstein discovery is trying to do with the model that it has right now is trying to predict why the difference, why there is a difference, and the reasons, the piecewise, the piece clues or the piece individual contributors to this difference. So, for example, female by itself is good. As ED looks at the data, it sees most of the F female have yes, most of them have yes, so that's a good thing. How much is good? There's an equation, it's in the help doc. I mean, the impact is 27, is based on the coefficient, preclude sum, etc. But pretty much that's the number. Don't get stuck at the number. It's just pretty straightforward math what it is, but that is, again, you want to look at it as an accuracy overall, not by piece. But the business scientist or the super user might be looking at the story, by the way, from this side in the beginning. We're not talking about the end user who consumes the prediction and sees the explanation, something like this. We're going to see it in the other, again, videos. But here we're really deep diving into some of the business reasons. Okay, in this case, not business, but the reasons why female average survival is much higher. You can look at things, for example, that are combination. This is bad. So even if it's a female, if it's a class 3, it's a bad thing, and it's, minus 2.4. We will see unrelated small contributors. They're too small. We don't want to spread them out in their own explanations. And very interestingly, right here is unexplained. Unexplained, what it's trying to say here is like, look, there is a model by ED. However, that model is, there's something, there's a piece of that, step is unexplainable. The model, this is the magic word, is not overfitting. We're not trying to find an explanation exactly why this is 74. There's something, we just don't know why it is. That gap, that thing, I see it right there and tells me, okay, the model is not overfitting. So when I deploy it in production for a new set of data, it's not gonna, try to overfit or fail or etc. It's just like it is sincerely in this particular case, there's something unexplained. Now, how do I fix that? Or I don't know if I need to fix it because I'm going to go look at the predictions metrics. That's a separate talk track, but it is okay to see some unexplained right here. And again, you can check this, you can compare it, etc. I'm going to go next to predictions. So this is where I can do a quick what-if analysis. So let's say, I'm going to take a ticket and I don't know what fare maybe I should select, and I do want, let's say, class 2, and I don't have siblings and I don't have parents at my age. Okay, I'm gonna cheat here and say I am 28, and so that's the action variable. What's my prediction right now? I'm not gonna survive. What to do to improve that? Well, change my fare. And this is why it's saying that. These are the reasons. Now, again, this is your typical what-if analysis. It's very powerful in the hands of a super user, not necessarily the end user who's going to see this. And of course, in the context of a business problem, not like this general or hypothetical problem. And the last thing here is the model metrics. So you can see here's where the statistics comes in. Here where I need to know what's an AUC. This is a binary, so it's a little bit more complex than a linear or your typical R-square. I have my current threshold selected for me. I have my top predictors. I have my outcome variable distribution. This is what I saw in the lenses. Cross-validation passed. And there I have some recommendations. So we're going to come to those in a bit. You're going to see, like, you can see them here. You can see them there. Model evaluation. So again, I have all these metrics. I have the gains and lift charts. If you really want to dig into this statistically, cross-validation and all of the metrics, the coefficients that are being created for each particular value of the dimension, right? Sex is female, sex is male. Everything has some coefficient. And you can, again, dig deeper into the threshold, into the confusion matrix. You can play around the confusion of the threshold so you can increase. This is where, again, the statistics knowledge, or maybe if you have a data scientist in your team, will help you, validate what looks like a good metric, good model or not. And you have some sample predictions. This is back on the same data. And you can see that most of the predictions here are true, but I do have some falses. And this might not be enough for me. Now, again, these look good, but I don't know, this is enough or not. This is just 100 randomly. I will go by, again, model evaluation and figuring out those performances gains right here. And like I mentioned, the recommended updates, well, it is saying P-class and FAIR look very similar. This is one of those where I said, mentioned previously, the business knowledge and coordination. So for example, for me, if I'm dealing with this strictly from a data perspective, I don't have enough information maybe, to say, hey, always it's a higher fare with a higher class, because I'm gonna have to go maybe to the the selling department team or promotions or something to know, do you have that always higher fare with a higher class, or do you run some promotions? Is there an indicator I have to add to my data to know which record was actually a promotion and hence the fare was lower, etc. So I can't take that decision just like this. That's one option, to go back to the business and talk, or I can write down or check, not write down, I can compare the model. I can change this and say just P class, deep P class, or do these bucketing, whatever. And then I will compare these metrics to the new model and see which ones are better or not. This is why iteration is going to be a lot. And last things, just to show you really quick, again, you can deploy the model from here. You can check the version history, deploy model. There's a separate video right there on it. But that's pretty much it. Again, you can, how to upload the data CSV. In this case, I do recommend, just if you have access to these environments, just go and upload a data set you're familiar with, and play around. Look at the insights, look at the predictions, look at the model, and start getting a little bit familiar with this. Now, these environments are limited in the sense of you can upload only, you can run stories on data sets of 50,000 rows, if I'm not mistaken, and 12 fields, just because the power is kind of watered down on these free environments. But for limits, and I will mention limits, you can always go to the main help link, and for Tableau CRM, scroll down to Einstein Discovery, scroll down to get started using Einstein Discovery. You're going to see Einstein Discovery limits, and you're going to see all these limits in the production environments, right? So, how much data set, how many columns you can add, story limits, and then deployed predictions, how many predictions you can run, per org, per field, per day, etc., etc. So make sure you are aware of these, especially if you're deploying in a high number of end users or expected predictions to be scored, etc., etc. There's a lot of things here that, again, we're going to cover through the other videos. Now, one thing I do want to finish up really quick. So we talked about story and model, etc. really quick. We talked about deploying it. The last thing is, and there's a separate, again, video for this, is the model manager. Don't forget, everything you deploy, eventually you want to monitor, you want to check, if there's alerts, if there's any settings, etc. You can always go back and check those out, okay? And again, we are going to follow with more information in the other videos. But with that, this particular long intro to ED, hopefully we've covered most of the topics. Now we're going to go and actually pick an actual Salesforce object, go through the story a little bit deeper, and cover a little bit more, deployment of predictions model managers. And we're going to cover also some of the best practices when it comes to using Einstein Discovery.